Hello, welcome back to Pwime Numbewednesdays. Today we're going to take a look at some Mersenne numbers in not just one dimension, not just two dimensions, but in 3 dimensions. First of all, a quick recap. The Klintberg conjecture turned out to be true. There's a proof video about that, and you can go watch that if you want. This was the conjecture, which is true. Take any odd prime p, and then p divides the Mersenne number, where the exponent is 1 less than that prime number. Can we show this visually? Here's a quick recap of Mersenne numbers in binary. First of all, a power of 2 can be written in binary by just putting a 1 in the spot of that power of 2. So 16, for example, in binary, is a 1 in the 16 spot and then a 0 everywhere else. So this shows that the number of zeros is the same as whatever the exponent is. So for example, 2 to the power of 4, which is 16, has 4 zeros. The Mersenne number, 1 less than a power of 2, is a string of 1s in binary where the number of 1s is the same as the exponent. So for example, 2 to the power of 4 minus 1 is a string of 4 1s. So going back to 1 less than the prime, we can represent that in binary by a string of 1s where the number of 1s is the same as the exponent, p minus 1. So what this says is that p divides in binary a string of 1s where the number of 1s is p minus 1, or put more explicitly, p divides 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus however many terms it is that makes up p minus 1 terms. Now, we worked on showing this visually using some rectangles. Here's the binary breakdown, 1 plus 2, and we can see that yes, 3 does divide this. We can see it with our eyes as a side length. Again, here's the binary breakdown, and represented visually, 1 plus 2 plus 4 plus 8. And we can see with this representation that yes, 5 does divide this. We can see that very clearly on the side length. Again, here's the binary breakdown, 1 plus 2 plus 4 plus 8 plus 16 plus 32. And we can clearly see that 7 divides this. Here it is again as a side length. 9 does not divide this, even though we can show it as a rectangle, because it's still a Mersenne number, and it is still represented by this binary breakdown, but 9 does not divide this. 9 is not a prime number. And then 11 does divide this, but the rectangle doesn't show it. We do know that this side length is 33, and so we can do the calculation in our minds, but this rectangle doesn't clearly show why 11 should divide this Mersenne number. It also really doesn't explain why 9 wouldn't divide this rectangle. These rectangles don't quite cut it. So today, let's try a different approach. Here is our binary reminder. Let's use grapes. Here's our prime number. 3 divides the Mersenne number where there are 2 terms that we're adding together. So 3 divides 1 plus 2. To show this, what we could do is we could do a 1 and then plus a 2. But thinking ahead, we're going to want to add more with other examples. So let's do this instead, where we start with 1, and then we branch out from that 1 to add one on each side. And then with other examples, we can branch these out to have one on each side, and then we'll be for sure doubling each time. Here's 1 plus 2 in 3 dimensions, although really it just works in 2 dimensions. And we can clearly see that yes, 3 divides this. Now we have next prime number, 5. 5 divides the Mersenne number where there are 4 terms that we're adding together in binary. So 5 divides 1 plus 2 plus 4 plus 8. 5 divides 15. How can we show this? We'll take 1 and we'll put a purple grape on each side. And then from each of these, we'll branch these out for these 4 green grapes. And now, let's branch out each of these. And just to make that a little bit easier, I think we'll go this way instead. Here it is. So now, first of all, looking at just the green grapes, we can see there's 5 green grapes. And then looking at the purple grapes, on this side, here's 5 purple grapes. And on this side, here's 5 purple grapes. We can clearly see that 5 does divide this. And we found a way to represent it in a way that shows the doubling each time. Now, with the prime number 7, it divides the Mersenne number where there are 6 ones in binary. So 7 divides 1 plus 2 plus 4 plus 8 plus 16 plus 32. So 7 divides 63. And here it is. Now you'll see that I've grouped the green and the purple differently than I did before. Before I was doing green, purple, green, purple, green, purple. But this time I've grouped this half all the same, and you'll see why in a moment. I won't do the entire thing with all of these grapes and the toothpicks, but I will show it to you in a drawing. So let's just start with these. Now, with all of these purple grapes, this would get far too crowded to see what's happening. But as before, we would just continue the same pattern where this would get 2, this would get 2, this would get 2, and this would get 2. That would take in all of those 8, and then each of those ends would also double to add on the 16, and each of those ends would also double to get 32, and here's what it would look like. So here we can see the 7 green grapes in the middle support all of the groups of 7 on each branch of the purples. So we can clearly see from this diagram that 7 divides 63, grouped this way. Now, as for the next prime number, which would be 11, 11 is going to divide the Mersenne number where there are 10 ones. So 11 divides 1023. So we won't do that with grapes today, but can we do that with a similar representation where we keep branching from the latest grape that we've added, just branch it out to add 2 onto each of those ends? Well, so far this is looking very promising, except for one thing. The coloring system changed. So we don't have a set way of knowing where is the prime number going to show up. How are we going to see it in this branching representation? As soon as I realized the coloring isn't necessarily predictable, that got me thinking again about the binary representation. The reason that those representations worked so well is because of how these particular binary numbers line up so neatly.
5 in binary is 1 plus no 2's plus a 4. This column here was the 1 green grape. This column here, those were the 2 purple grapes. This column here were the 4 green grapes. Likewise, this representation with all of the 7's, 7 is 1, 1, 1 in binary. It's 1 plus 2 plus 4. Each column is uninterrupted by any other column. They just translate directly. Could this work with our next prime number, which is 11?
I haven't tried it with grapes, but let's try writing it out on paper. Here we have 11 written out in binary. It is 1 plus 2 plus 8. And here is my binary algorithm to see that yes, 11, the number, does divide the Mersenne number represented by a string of 10 ones in binary. 11 divides 1023. So we can do it. The difficulty with this now clearly shows that we start out with each column has its own 1, but then we start having to carry into other columns. It gets very messy, so we wouldn't have a one-to-one translation of one particular column all being represented in one step in this kind of representation. Hang on, maybe we could still make it work. We want to be able to show that 11 stands out as a recurring group. Maybe all of these could be green, all of these could be purple, all of these could be green, purple, green. So we would have 1 green, 2 green, 4 purple, 8 green, 8 purple, 8 green, 16 green, 16 purple, 32 purple, 32 green. I don't know, this seems like it's just going to be messy. So really, this algorithm shows more clearly where each number goes than this would. And the whole point of seeing something visually is to see it more clearly. So although I haven't tried drawing this out, it is 1023 after all, it just seems like this might be a dead end. I still believe there's value in showing this visually. How can we see that the prime divides the Mersenne number? And why do we want to see this visually? Well, because some primes also divide other Mersenne numbers that are an extension of this established pattern. So next time, which will be in 2 weeks, we'll look at other ways that we can visually explore this fact. There are so many ways and approaches to show something visually. Meanwhile, have a meaningful and caring Remembrance Day. I'll see you next time.